In this lesson, we will be solving 3 examples of initial value problems using the method of the Laplace transform, where the non-homogeneous term is a discontinuous function. So this function right here is sometimes called a forcing function. So we'll be doing then an example, 3 examples where the non-homogeneous term is a discontinuous function. So the easiest case is when you just have a step function. That is the easiest type of discontinuous function. It's just 2 parts and there's a jump. In this case, right at 2. Okay, so let's get started. Remember that for the method of Laplace transform, you always start the same way. So we're going to start this method, solving this equation the same way we always do, regardless of whether this is continuous or not. So we start by taking the Laplace transform on both sides. So put L on both sides. So this is going to be, and also remember that you can use the linearity to split this up and pull out constants. So this is going to be then the Laplace transform using the linearity of y double prime plus 3 times the Laplace transform of y prime plus 2 times the Laplace transform of y equals the Laplace transform of u sub 2 of t. Okay, now for this part, we need to know what is the Laplace transform of the second derivative. And that is one of those formulas that I told you we're going to be using over and over again. It's in the table of formulas. It is, oops, sorry. It is this one right here. Let me see, it is this one. But what is the Laplace transform of a derivative? The first derivative, the second derivative, third derivative. It is this formula right here. And we're mostly going to be using the first 2 cases, maybe the third. N equals 1, n equals 2. So you can look this one up, but because we already used it. So this one is the Laplace transform of the second derivative using that formula for n equals 2 is going to be s squared Laplace transform of y minus s y 0 minus y prime at 0. So all that is the Laplace transform of the second derivative. Now, plus 3 times, now we use the same formula with n equals 1 to figure out what is the Laplace transform of the first derivative, and that is just s times the Laplace transform of y minus y naught. So this is 2 Laplace transform of y plus 2 Laplace transform of y equals, and then we look this one up on the table, Laplace transform of u2, because you don't have to memorize this. So, it is this one, c equals 2, so e to the negative 2s over s equals e to the negative 2s over s. Okay, it is convenient to write these ones down. Maybe you can include them in your formula sheet. You have this general formula, but it's kind of easier just to write down what is this formula when n equals 1, n equals 2, when you're doing the homework. All right, so next. Now we're going to simplify by plugging in what these things are. So we're going to plug in y naught, y evaluated at 0 equals 2, and y prime at 0 equals 5. So this is going to be s squared Laplace transform of y minus y of 0, this is going to be 2, so minus 2s, and then y prime at 0 is 5. So minus 5, this is a 5, not an s, plus 3, and then this one is a 2, so I'm just going to distribute it once. So this is 3s Laplace transform of y, and then I said this is a 2, so minus 6. Minus 6 plus this Laplace transform of y equals e to the negative 2s over s. Okay, now we're going to solve for Laplace transform of y. So we're going to collect these like terms, and then everything else needs to go to the other side, because we want only the Laplace transform of Laplace transform of y. Okay, collecting the coefficients, this is s squared plus 3s plus 2. And then on the other side we have e to the negative 2s over s, and we're moving these two terms and that one, so we can collect minus 5 and minus 6 is negative 11. When you move it to the other side, it becomes plus 11, and this one becomes plus 2s. So plus 2s plus 11. All right, and then we divide by this, and we have solved for the Laplace transform of y. Laplace transform of y is going to be, and now we divide, so I'm going to write e to the negative 2s times, I'm going to write this like this. We have this s, and this also goes down, so s squared plus 3s plus 2, and then all of that divided by the same thing, but without the s, because that s is just for that one. Okay, s squared plus 3s plus 2. Alright, so we see we solved for the Laplace transform of y. The Laplace transform of the solution which we're looking for, we want to find y. We know what the Laplace transform of that y is. It is this. So from this, we should invert the Laplace and figure out why y needs to be, which is going to be the solution. Alright, so we need to invert that, and we need to invert that, and if you remember, this is just like the very last example in the previous lesson. We need to use partial fractions in this, and we need to use partial fractions in that because these things are too complicated and they're not on the table in that one as well. So we need to break this down into easier parts. Okay, so I'm going to do this in purple. So we have to break this part down. So let's see, this is 1 over s squared plus 3s plus 2. Well, this factors as 1 over s, that factors easily as s plus 2, s plus 1. And then, because of that factorization, this breaks up into 3 terms, a over s plus b over s plus 2 plus c over s plus 1. Okay, now let's use Heaviside cover-up method. We multiply, so we can ignore this part now. We're going to multiply both sides of this by this bottom, by this denominator. We're going to get 1 equals, and then when you multiply by that, the s cancels, so you end up with this part. S plus 2, s plus 1, plus, now b, the s plus 2 cancels when you multiply by this, and now you are left with s plus 1. In the last term, the s plus 1 cancels, so you end up with s plus 2. Okay, now you plug in the numbers that make each of these terms 0. So let's start by plugging in -1. That makes this term right here 0. It makes this one also 0. So you end up with 1 equals, and then plugging in -1, this is c times -1 times 1. So that means that c is -1. Okay, c is -1. Now let's find out what this one is. So we're going to plug in s equals -2. That kills the first one, and that kills the third one. So you end up with 1 and then the middle one. So 1 equals s equals -2. So this is going to be b times -2. -2 plus 1, -2 plus 1 is -1. So you get then that 1 equals 2b, 1 equals 2b, and dividing by 2, you're going to get that b equals 1/2. Okay, and then lastly, we plug in s equals 0, because that's going to kill the middle term and the third term, and just going to leave you the first one. So this is going to be then 1 equals, that goes, and this is going to be a times 2 times 1. So that means 1 equals 2a, and then divided by 2, you get a. So that means a equals 1/2. Okay, so those are all the coefficients. That's the numbers that go there. And now we have to break this one up as well. So now we have to do the same process all over again and break up that one. Okay, so now let's break up 2s plus 1, or decompose, perhaps is a better word, because this is called partial fractions decomposition. So 3s squared plus 3s plus 2, well, this is 2s plus 11 over s plus 2, s plus 1. And then, because of the two terms, both linear, the terms on the top of each of these has degree 1 less, which is 0. So s plus 2 plus e over s plus 1. That should be, the decomposition is going to be like that. And now we need to figure out what d and e are. So multiplying both sides of this equation by this bottom, you're going to get 2s plus 1 equals d s plus 1 plus e s plus 2. You could have used a and b again. I mean, you had enough if you don't get confused, but I already have these right here, so I decided to use d and e. Okay, now we plug in, let's plug in s equals -1. If you plug in s equals -1, that goes, and you end up with, what do you get here? If s equals -1, you get -2 plus 11, which is 9. And if you plug in -1 here, -1 plus 2 is 1, so you get e times 1. E times 1 is just e. Aha, so you get immediately that e equals 9. Okay, e equals 9. Now let's continue. another page. Okay, e equals 9, and now let's plug in s equals -2. And now we're going to plug in s equals, oh, that's 2. Okay, plug in s equals -2. So we're going to get what? -4 plus 11 is 7. And then here that goes, and that you get -2 plus 1 is -1. So that means D is -7. D is -7. Okay, now we have the entire decomposition, so we can go back here and decompose everything and write down. The Laplace transform of y equals e to the -2s, and then let's write down here what this is broken up, and it is this, where a equals a half. So I'm going to write a half over s. B equals a half as well. So a half over s plus 2. And C equals -1. So -1 over s plus 1. Plus, now the composition of this one, which we have it right here. It is d over this plus e over that, and we found what both d and e are. So plus d is -1, -7. So -7 over s plus 2 plus e, which is 9, over s plus 1. Aha. Now we have the Laplace transform given in simpler terms. Now I think in 1 or 2 steps we should be able to invert the whole thing by looking it up in the table. So one more step. I want to distribute this because I cannot find the whole thing at once on the table, so I need to distribute it. And I'm going to put the constants which usually don't really matter in the front. So this is going to be 1/2 times e to the -2s over s plus 1/2 times e to the -2s over s plus 2 minus e to the -2s over s plus 1 minus 7 times 1 over s plus 2 plus 9 times 1 over s plus 1. Okay, now each of these are in the table, and we're going to look them up. Okay, this one right here, e to the -2s over s, is this one right here, e to the -2s over s, where c equals 2. So we can invert to this one using number 12. We can invert to this one using number 12. This one, we're going to have to just use this one. E to a power. Think about it like separately. E to a power times 1 over s plus 2. Same with the other one. And these ones, oh, these ones are a little bit easier. That one is just that with a equals -2, and the other one is the same with a equals -1. So only this one, these two, kind of like so for this one we said this is number 2, and that's number 2. It is these two that we're gonna use. We're gonna use number 12 for both. Okay, so I'm just gonna take one more line to rewrite this slightly better and then do it, and then use the table. Alright, so this is going to be a Laplace transform of y equals 1/2 times e to the negative 2s over s plus 1/2 times e to the negative 2s times 1 over s plus 2 minus e to the negative 2s times 1 over s plus 1 minus 7 times 1 over s plus 2 plus 9 times 1 over s plus 1. Okay, I wrote it like this just so that it looks a little bit more like the formula. This one I didn't because this one appears just as is on the table. It is that one, but the other one is not exactly over s, it's s plus 2. So that means we cannot use that, so I'm writing it like this. It's gonna look more like this. Alright, so now, almost done. Now let's invert. So now, this is gonna be y equals, now I'm pulling L inverse on both sides, so I'm inverting. The 1/2 stays. The inverse of this is u2 according to the table. This one, u2, c equals 2 plus 1/2. And now this one is going to be this. So where c equals 2. C equals 2. C equals 2. So it's going to be u2 times this is the little f, so that's the inverse Laplace of the function right next to this. So that means I need to find the inverse Laplace of this and evaluate it not at t, but evaluate it at t minus c. Okay, this is tricky. You have to practice this. So I'm trying to invert something that looks like this. So it's going to be the Laplace inverse of this function, which is little f, but not evaluated at t, evaluated at t minus c. So I'm going to find the Laplace inverse of this, the Laplace inverse of that, but not evaluated at t, evaluated at t minus c, which in this case is 2. Okay, evaluated at t minus 2. This is evaluated. This is not a product. Okay, there's no multiplication here. I'm saying this is evaluated at t minus 2. Okay, this is not gonna fit in there. So the next term would be, now the inverse of this is similar, u2 t. Now we find the Laplace inverse of s plus 1, 1 over s plus 1, sorry. And then we evaluate not at t, but at t minus 2, because that's the c. Oops, and you have two more terms. Minus 7 times the Laplace inverse of that. The Laplace inverse of that is this, where a equals -2. So that's going to be e to the negative 2t. E to the negative 2t plus 9 Laplace inverse of that, which is the same as that, but a equals now -1. So a to the negative t. So e to the negative t, I should say. E to the negative t. Okay, so that is it. Now let's try to write it in a single line, because that's too messy with 3 lines. Okay, so this is going to be y equals, so now it comes Oh, not even, because we haven't done that yet. So what is the Laplace inverse of that? Okay, this is 1 half u2 plus 1 half u2 t. The Laplace inverse of this, it is this one, a equals negative 2, so it is e to the negative 2t, e to the negative 2t, but remember, it's not evaluated at t, it's evaluated at t minus 2. So t minus 2, then minus u2 t. Laplace inverse of this, it is e to the negative t, but not evaluated at t, is evaluated at t minus 2, minus 7 e to the minus 2t, plus 9 e to the negative t. Okay, that is it. You can simplify these if you want that, if you want to, and that disregard the minus if you want to, but that's not necessary. So that is the answer for that problem. Now we're gonna do another example, but this time now we have two u's in there in the non-homogeneous term. Two u's. Okay, so this is going to significantly make this problem a little, more tedious, complicated. The algebra is going to be far more complicated. Uh, but let's see what we get. Okay, um, start out by taking L on both sides. So that story is always the same. So take L on both sides. You're going to get, and I can pull out the 2 and break it up. So 2 using linearity. 2 Laplace transform of double prime, the second derivative, plus Laplace transform of the first derivative, plus 2 times the Laplace transform of y is going to be equal to the Laplace transform of u5 minus the Laplace transform of u20. Oops, I meant to write u20. By the way, this example right here is an example in the textbook. It's directly taken from the textbook. And in the textbook, they skip a lot of details. They skip a lot of the details. The problem for them is like, I don't know, half a page or something. They just tell you do this and do that, and if you do this, you're gonna get that. But they skip a lot of the steps. So I'm working out this example from the textbook in all the details. Okay, so then now let's do this. Is gonna be 2 times, and this is again like in the previous one. So what is the Laplace transform of the second derivative? Right there. S squared Laplace transform of y minus s y of 0 minus y prime of 0. And then what is the Laplace transform of y prime? It is this. S Laplace transform of y minus y of 0. So basically I'm just going to copy those. So s squared Laplace transform of y minus s y not, y is y evaluated at 0 minus y prime evaluated at 0 plus, now the Laplace transform of y prime is s Laplace transform of y minus y evaluated at 0 plus 2 times Laplace transform of y equals, know that. Laplace transform of u5, you can look it up in the table, and same with Laplace transform of u20. Laplace transform of uc is e to the negative c s over s, so Laplace transform of u2 is negative 2 e to the negative 2s over s, and then Laplace transform of u20 is e to the negative 20s, all that over s. So this is just then e to the negative 5s over s minus e to the negative 20 s over s. Okay. Now we plug in what this is. Y evaluated at 0 is 0. Y prime evaluated at 0 is also 0. And so that's 0, that's 0, that's 0. So that means this whole thing simplifies quite a bit. So it's going to be 2s squared, those are 0. The Laplace transform of y plus s Laplace transform of y, and that is 0. So plus 2 Laplace transform of y equals e to the negative 5s over s minus e to the negative 20s over s. And now we can factor out the Laplace transform. Laplace transform, and where the coefficients would be 2s squared plus s plus 2. And then you still have that. And now divide by this, and we will get the formula for the Laplace transform of the function we're looking for. So Laplace transform of the solution y is, so just divide both sides by this, and we're gonna get, this is what we're gonna get. I'm gonna pull out a 1 over s from these. So this is like e to the negative 5s minus e to the negative 20s times 1 over s. I'm just going to do that to simplify it a little bit. And then what we get here is e to the negative 20s, negative 5. E to the negative 5s minus e to the negative 20s times 1 over, and then you have this s, and you have that. So this is 2s squared plus s plus 2. Okay, now this part we break it up using the partial fractions decomposition technique. Okay, so let's break it up. We're gonna get, because that's the factorization, and by the way, this part does not factor anymore. That's irreducible. You cannot factor that. You can try, you cannot factor it. So this is going to be 1 over s 2s squared plus s plus 2. So that means this breaks up as a over s plus, and then since this one doesn't factor, that's just going to be the bottom. And the top has to be a polynomial degree 1 less, so a linear polynomial, which means it's going to be with the form ps plus c. So that's going to be the partial fraction decomposition. Now, multiply both sides by the denominator. You're going to get 1 equals a. The s is cancelled, so you get 2s squared plus s plus 2 plus, now multiply this one. The bottom cancels, so you only end up with s. So b s plus c times s. Okay, then let's plug in. Plug in. So if we plug in s equals 0, we can kill this one. So why not? Plug in s equals 0. That one goes, the entire thing goes, and here you would get 1 equals a times, what do you get when you plug in 0 here? 0, 0, and 2. So a times 2, so that means that a equals a half. A equals a half. And now, if a equals a half, that means I can put that over here. That means that 1 equals a half, oops, well, 2s squared plus s plus 2 plus bs plus c times s. Okay, so now that's what it's looking like because we found a. Now let's plug in another number. Plug in s equals -1. It could be any number you want because at this point there's nothing else that you can plug in to kill that or that because you don't know what these are. So at this point that means you can just plug in anything. It was ugly, so I'm fixing it. I'm probably gonna make it worse. Okay, 2s squared. Alright, so if you plug in -1, so we're sticking to easy numbers. 1 and -1. Let's start with actually +1 first. Let's start with +1 first. What's wrong with this? Okay, let's start with +1. S equals 1. So we're gonna get 1 equals a half 2 plus 3 plus 2. So that's 5. Plus, and I'm plugging in 1 for S, that's B plus C times 1. So that gives you that B plus C, moving this to the other side, is 1 minus 5 halves. 1 minus 5 halves is 3 halves. Okay, 1 minus 5 halves is 3 halves. So we get this. We cannot really get C or B just yet. We're going to have to plug in another number. And we're going to get a system of linear equations. Let me plug in -1. That's going to be easier. Okay, we're going to get a system of linear equations, 2 variables, 2 equations. We can figure it out from there. So plugging in -1, we're going to get 1 equals, plugging in -1 here, 1 half times -1 squared is +1, so 2 plus -1. 2 plus -1 is 1, plus 2 is 3. And then -1 there, that's going to give us -b plus c times -1. Which, moving the 3 halves over there and distributing this, you're going to get b minus c, b minus c equals 1 minus 3 halves. 1 minus 3 halves is -1/2. So we have this system, again, that we're going to solve. What is the system? Well, the system is that equation and that one. So b plus c equals -3 halves, and b minus c equals -1/2. And you can solve this any way you want. So obviously, the easiest way in this particular case would be to add down, and then you will get 2b equals, that would be -4 halves. -4 halves is -2, so that means b equals -1. b equals -1, and if b equals -1, then you can plug in that in either of these and get c. So we can just say subtract the b, so that you're going to get c equals 3 halves minus b from the first equation is negative 3 halves minus negative 1. So that's actually then adding plus 1. So negative 3 halves plus 1 is negative a half. Aha, so finally we got the decomposition for this. Now we can go back and write this. So that means the Laplace transform of y is equal to e to the negative 5s minus e to the negative 20s times this, but this splits like that where we just found the coefficients. So times a equals 1/2, so 1/2 over s plus bs. B, what is b? B is negative 1, so negative s plus c, c is negative a half, all that over 2s squared plus s plus 2. Okay. Now we're going to, well, now we have to distribute here. Because again, there's no way we can find these on the table. We have to write this in simpler terms. So we're going to distribute this. We have to FOIL. So this times this times that, this times that. So you just FOIL it. So this times this is 1/2 times e to the negative 5s over s minus e to the negative 5s times, I just pulled the minus from both of them. If you pull the minus from both of them, you can put it in front and then they become both positive. So plus 1/2, all that over 2s squared plus s plus 2. Now this times that minus e to the negative 20s over s and the 1/2. I'm going to write now. So minus 1/2 is 1/2. And lastly, this times that one. Remember, you can pull out the negative from these two. So they both become positive and you have like a negative in front. And then this other negative gives you a positive. So you're going to get positive e to the negative 20s times s plus 1/2, all that over 2s squared plus s plus 2. Okay, now you try to look this up in the table to invert them. And this one is on the table, no problem. This one is on the table, no problem. This, there's absolutely nothing like that on the table. Nothing. So what you need to do is you look at how they all are written. We're going to have to complete the square. Okay, so we're going to have to complete the square here. So this is going to be 1/2 e to the negative 5s over s. So I'm just copying that one. Minus e to the negative 5s times s plus 1/2. And then let's complete the square on the bottom. You factor out the 2. Let's complete the square. I'm going to do that part in another piece of paper. So we're going to complete the square this here. So 2s squared plus s plus 2. So you factor out the 2 from the first two. You get 2 s squared plus 1 half s, and these two is that. So, okay, now complete the square, divide this one by 2 and square it. Dividing that one by 2, 1 half divided by 2 is a fourth. Squared is 1 over 16. So that's what completes the square, but now I have to take it away because it was not there. But that's been multiplied by 2, so I'm actually adding 2/16, which is 1/8. I'm adding 1/8 that was not there before, so I need to take it away. I was adding 1/8, I need to take it away 1/8. So then this is 2s squared plus 1 half s plus 1 over 16. And then this is multiply top and bottom by 8. This is 16 minus 1, which is 15, positive 15 over 8. And lastly, writing this as an actual square, we completed the square. This is 1/4 squared, or is a term in the middle divided by 2. Squared plus 15 over 8. Okay, so now that means this, you can rewrite it like that. So this is 2s plus 1/4 squared plus 15/8. Now I just keep copying. This is minus 1 half e to the negative 20s. And then the last term plus e to the negative 20s times, and now I'm going to rewrite it like this because I already did that. This is 2 times s plus 1/4 squared plus 15 over 8. Alright, now it is still not quite on the table because again, just look what the things on the table look like. It's still not quite good. Okay, still not quite ready because you have to have it as a square s of the form s minus a or s plus a, doesn't matter, squared, and there should not be a constant in front of that. You see, there's in none of these there's a constant in front of that. So in front of the square there shouldn't be a constant, and I have a 2 in there. So we need to fix this. So this is still not quite ready. So this is going to be 1 half times e to the negative 5s over s minus e to the negative 5s times, now you need to pull out that 2, so I'm going to factor out a 2 from both, and this is going to be 1 half, I'm pulling that 2 out away, plus 1 half all that over s plus 1/4, and then I factor out a 2, so that means I'm dividing by 2, so this is 15 over 16. Okay, minus 1 half e to the negative 20s, and then this last term, plus e to the negative 20s times s plus 1 half, all that over, and I have to do the same thing here. I'm factoring out the 1 half, pull out 2 from there, that means you're dividing the whole thing by 2, putting it in front, so this is plus 15 over 16. Okay, and now look at this. Now it's looking more and more like what is on the table. It's looking better. So it is of the form s minus or plus a squared. So there's no coefficients. We got rid of the coefficient. plus something squared, something squared. We're this is the one that has an s on top, so it's actually going to be this one. This is the one that has an s on top, s and a number. That number though needs to be exactly the same as that number. Is it? So we have a half there and we have a quarter there. So there's a problem. There's a big problem there. We need to fix that. So this A has to be the same as that A. And then this one we have to write in the form of something squared. Okay, so just one more issue that needs to be fixed and we're almost home. So I know these problems are like really long. These are, by the way, I think this is actually the hardest problem in the whole semester. This lesson. All three problems are tedious. Okay, so now this is 1/2 times e to the negative 5s over s minus 1/2. And we need to fix that. So how do we fix that? I say I wanted the same number here. I need a quarter, so that means I need to put a quarter there and spread that out. So 1/2 e to the negative 5s. So I need a quarter there, so this is going to be s plus 1/4 over s plus 1/4 squared plus, and then we need to write this one as a square of something. This is going to be, if you take the square root of that, that's square root of 15 over 4. So if you square that, you do get back 15 over 16. Okay, and then this quarter, I borrowed a quarter that I needed, so I still have another leftover quarter. I have to write 1/4 over that denominator, s plus 1/4 squared plus square root of 15 over 16 squared. Okay, and then I still have these two terms. So minus 1/2 e to the negative 20s plus 1/2 e to the negative 20s, and I need to do the same for that one. So s plus 1/4 over s plus 1/4 squared plus square root of 15 over 4 squared plus this one. Okay, it's not going to fit in there, I don't think. Plus 1/4 over s plus 1/4. I'm going to try to make it work. Whew. Okay, now it's good to go. Now we can invert this. Finally, finally, finally. So this is going to be equal to. Now let's see. Inverting the first one is the easy one. So inverting that one is just u is going to be u5 because the c is 5. So because it says e to the negative 5s over s, that means the c is s in this one. So this is just going to be u5. Okay, that's just u5 minus 1/2 and then maybe I should have just distributed this. Yeah, let's do that. Let's distribute that first. It's hard to keep track of so much crap. So this is e to the negative 5s over s minus 1 half e to the negative 5s times s plus a quarter, all that over s plus 1 quarter squared plus square root of 15 over 4 squared plus distributing, you're going to get negative a half e to the negative 5s times 1 quarter, all that over s plus 1 quarter squared plus square root of 15 over 4 squared. And then just distribute that one as well. So this is negative a half e to the minus 20s plus 1 half e to the negative 20s times s plus a quarter, all that over s plus 1 quarter squared plus square root of 15 over 4 squared plus, I'm distributing, remember, so this is 1 half e to the negative 20s times 1 quarter, all that over s plus 1 quarter squared plus square root of 15 over 4 squared. Okay. Now we can invert. So this is going to be 1 half. This is what I had. U5 for the first one. This is minus 1 half. Now, how do you invert to that? Well, this is going to be, I have e to the negative 5s times something. So this is going to be u5, because the c is 5 in this one. This is going to be u5 times, remember what this is, the Laplace transform of s plus a quarter over s plus 1 quarter squared plus square root of 15 over a quarter squared, because the formula tells me is the Laplace inverse. I should be the inverse. Yeah, I wrote the inverse. Okay, the Laplace inverse of the thing that is right next to the exponential, but not evaluated at t, evaluated at t minus c. So that means evaluated at t minus 5. And then this is plus negative a half e to the minus 5s. No, it's the same as that actually. It's the same as this. So negative to the 1 half u5 t times the Laplace inverse of the exact same thing. Exact same thing. So I'm just, well, no. No, almost the exact same thing. Now I have just a quarter. So a quarter s plus 1 quarter squared plus square root of 15 over 4 squared. Evaluate it not at 5, but not at t, but at t minus 5. So that's inverting this one. Now you have to invert to that one. That one is just minus u20, minus 1 half u20. Now these two are basically those two again. So you see this is very time consuming. So plus 1 half. I think this homework only has like very few problems. That's why. Plus 1 half e to the negative, sorry, inverting that is u sub 20. U sub 20. I'm inverting this one. U sub 20, Laplace inverse of this. So it is exactly the same thing as this, but instead of evaluate at t minus 5, is evaluate at t minus 20, because the c is 20 now. So Laplace inverse of this. Now once we do it once, we're just going to do it, copy it twice. evaluate it at not t, but at t minus 20, plus, now invert this last one right here, so that's going to be plus 1/2 u20, Laplace inverse of that, evaluate it not at t, but at t minus 20. Okay. Now, we're going to look these two up, and we're almost done. Ah, hallelujah. So, look these two up. That's repeated. So, this is the same as that, and this one is the same as that. So, look these two up. That is this one right here, where b is the square root of 15 over 4, and a equals 5. It is this one. So a equals 5, b equals the square root of 15 over 4. And remember, this whole thing is not evaluated at t, but at t minus 5. Okay, so for the first one. So let's start. So this is going to be 1/2 u sub 5 t minus 1/2 u sub 5 t times, we just said, e to the 5t. But remember, is not 5t, is, oh, is a, sorry, is not a, a is a quarter. Sorry, a is a quarter. So e to the 1/4, oops, so it's going to be 1/4, 1/4, and because this is positive, this has to be a negative, because the a is actually positive. The a is actually negative 1/4, because I have positives in our problem. We have plus 1/4, plus 1/4. So a is actually negative 1/4. So ae to the negative 1/4 t, but remember it's not at t, is at t minus 5. So t minus 5 times the cosine times b squared root of 15 times the cosine square root of 15 over 4, and then times t, but not t minus 5, t minus 5. Okay, so that inverts that one. Now this one, I mean, that's done. We don't have to do anything to that one. Oh no, that's not done. Now we look this one up. This one is that one. Oh, you see what happened there? The one we want on top now of this one is not the A, is not the quarter, is actually this thing. The square, the B needs to be on top, otherwise it's not gonna work. So that means this is not good, because I don't want a quarter there. I want the square root of 15 over 4. So that means we're going to have to add the square root of 15 and divide by the square root, 1 over the square root of 15 before we can actually do this one. Okay, so let's add it. We have to add this in here and multiply. So I'm multiplying the top by square root of 15 and dividing by it, so that I don't change things. Yeah, this one, it needed to be the b on top. See how tedious this is? So square root of 15 over 4 squared. Evaluate at t minus 5. And then continuing here, minus 1 over 2 u20 of t plus this one, 1 half u20 of t. And then this one is the same as that, but instead of t minus 5 is t minus 20. So t minus 20. And lastly, we just copy this one modified. So this is 1 half times u20. And remember, we need a square root of 15 over 4 there. So we have to do multiply Laplace inverse of square root of 15 over 4 over s plus 1 quarter squared plus square root of 15 over 4 squared at t minus 20. And now this thing appears on the table. Finally, it is b, it is this one, b over s minus a squared plus b squared. Now I have these two matching, and it's going to be the same thing as that one actually, but with the sign. So you see these two are exactly the same. It's just going to be the same but with a sign. Okay, so this is then 1 half u5 of t. So this minus 1 half u5 of t times e to the negative a quarter, t minus 5 cosine, square root of 15 over 4, t minus 5, minus a half u sub 5 of t times 1 over square root of 15 times, remember the inverse of this is now the same as this but with a sign instead. So e to the negative 1 quarter t minus 5, no, it's going to be, yeah, it's 5. We're still with the 5, this one. Sine of square root of 15 over 4 t minus 5. And then the last two are like a repetition of some of those, but with 20 instead of 5. So minus 1 half u20 of t plus 1 half u20 of e to the minus a quarter t minus 20 cosine. Oops, my bad, I was out of the frame. Square root of 15 over 4 t minus 20. And then lastly that term plus 1 half u20 t over 1 over the square root of 15 e to the negative a quarter t minus 20 sine square root of 15 over 4 t minus 20. Okay, That completes the hardest problem in the entire semester. Now we're going to do one last example. And again, as I said, this is really the hardest and most tedious lesson of the whole semester. Once we get past this section, the rest is going to be a lot easier. Um, yeah, so we're just going to do one more of these and then be on a on an easier material for the rest of the semester. So this problem says we have to solve this IVP where G is given by this. Like the first thing we need to do is really try to rewrite G in terms of the U's, in terms of the Heaviside functions. So that's going to be the first order of business. So this is going to be G of t. And then we're going to write this in terms of U's, we're going to break it up. This is the same as 0, 3 for t between 0 and 6, not including 6. And for t bigger than or equal to 6, plus t halves 0. So you see, where if you just add across, 0 plus t halves is t halves, and 0 plus 3 is 3. So I broke it up into the sum of these two piecewise defined functions. Okay. Then you can do the trick we did before, factor out the non-zero term. So I'm going to factor out 3 from both of them. So this is 3, 0, 1. And then here factor out the t halves. So this is 1, 0. And now you can recognize these as this one as U6. And this one, you recognize it as 1 minus U6. Again, remember that 0, 1, that's U6, and then when it's reversed, then it's 1 minus U6. Okay, so then that is G. Then we rewrote this step function, this piecewise defined function, sorry. This piecewise defined function in terms of U, just like that, in terms of U6 in this case. So then that means that y double prime plus y equals 3u6 t plus t halves 1 minus, and we can actually distribute this right away now. So distribute that minus t halves u6 of t. Okay, now we can work this out. Take L on both sides, Laplace transform of both sides. Laplace transform of y double prime plus Laplace transform of y equals 3 times Laplace transform of u6 plus, you can say factor of the 1/2, Laplace transform of t minus, again you can factor the 1/2, Laplace transform of t u6 t. Okay, this one is readily on the table of Laplace transforms, and so is this one. This one is not, so this one is going to need a little bit of work. So before we continue, then I think we should work this out. So let's do that. So Laplace transform of t u6 of t. Well, we kind of did this stuff like this before. You actually need this. This needs to be translated um, at t minus 6. Right, like that, it doesn't work. It's not. It's not. You cannot do it like that. So this is gonna be because there's like a 0. It's like a t minus 0. Remember that those numbers need to match. So this is has to be a t minus 6 u6. But then if I add a minus 6 in there, that's like adding plus 6 u6. So plus 6 u6 t. And now you see if you distribute this, these two will cancel, you get that back. So this is correct. And then using the properties of linearity, you can break this up. This is a Laplace transform of t minus 6 u6 plus 6 Laplace transform of u6. And now there's no problem. Both of these are going to appear on the table. Actually, let's do that. This one, you see u6 times some function translated at the same number, so t minus 6. In this case, the f is just t, f of t equals t. So the Laplace transform of that is going to be e to the minus cs. So this is e to the minus c s. The c is 6, so minus c minus 6s times c is s times the Laplace transform of the function without the translation. Laplace transform of this without the translation, without the minus 6, times the Laplace transform of t. And then the Laplace transform of u6 is e to the minus 6 s over s times e to the minus 6 s over s. And the Laplace transform of t is this one. When n equals 1, when n equals 1, so that would be 1 over s squared. So times 1 over s squared. All right, so that is this one. Laplace transform of t u6 of t is this right there. Okay, so now let's keep working this one out. Laplace transform of y double prime, that is s squared, Laplace transform of y minus s y naught, y of 0 minus y prime of 0 plus, so keep working with this, the Laplace transform of y equals 3 times, the Laplace transform of this is e to the minus 6s over s, we look that one up, plus 1/2, the Laplace transform of that, we just did it right here, is 1 over s squared, and then minus 1/2, the Laplace transform of this, which we did, right here. So 1/2, negative 1/2, and it has to be distributed. So I'm gonna distribute, I'm just gonna write it like this and then distribute it, because then I'm gonna mess it up if I just try to do too much. Minus 6 s times 1 over s squared plus 6 times e to the minus 6s over s. Okay. Now let's keep working. Y of 0 equals 5. and y prime of 0 equals 4. So let's plug that in there. This is going to be s squared, Laplace transform of y minus s times 5 minus 4 plus Laplace transform of y equals this thing. Well, I'm going to distribute that in the next step. So this is 3e to the minus 6s over s plus 1 half times 1 over s squared. Now distributing that, that is minus 1 half e to the negative 6s times 1 over s squared. And then distributing that, it will be minus 3 times e to the minus 6s over s. And note that these two actually cancel because they're like terms and they're identical with opposite signs. See, they're identical. So those two actually cancel. And this simplifies some. So this is s squared, Laplace transform of y, minus 5s minus 4 plus the Laplace transform of y equals, and you're only left with 1 half times 1 over s squared minus 1 half times e to the minus 6s times 1 over s squared. Okay, now collect, you, you want to solve for L of y, so I'm going to keep these two, move everything else to the other side. So this is going to be s squared plus 1 Laplace transform of y equals, and these need to move. So I'm going to have 1 half times 1 over s squared minus 1 half times e to the minus 6s times 1 over s squared, and then these two move. So plus 5s plus 4. And now dividing, you're going to get Laplace transform of y equals 1 half times s squared x squared plus 1, because everything is divided by s squared plus 1, minus 1 half e to the minus 6s times 1 over s squared plus 1, plus 5s plus 4 over s squared plus 1. Okay, to invert this, you need partial fractions, and to invert this one as well. It's just the same fraction though. So you're supposed to do partial fractions for this. That one, this one you can do very easily. I'm just going to skip that. This actually decomposes as 1 over s squared plus negative 1 over s squared plus 1. Okay, I'm skipping that one because we already done several. Alright, so then using this back here, put it back there, put it back there, what do you get? You get the Laplace transform of y equals 1 half times 1 over s squared plus negative 1 over s squared plus 1. Or just can put a minus. Okay, and then minus 1 half e to the minus 6s. And you can write this again. S squared minus 1 over s squared plus 1. And then you have that term. which we can break up as 5s over s squared plus 1 plus 4 times 1 over s squared plus 1. So it's like 5s plus 4. And then you can actually also take this 5 and put it in front. So I'm going to do that. This is 5s plus 4. So I'll pull out the 4, and I'm going to pull out the 5 as well. Okay. Alright, so that's that. Now one more step and I think we will be almost ready. Just distribute everything. So this is 1/2 times 1 over s squared minus 1/2 times over s squared plus 1 minus 1/2 e to the minus 6s uh, 1 over s squared. Negative and negative gives you positive, plus 1/2 e to the minus 6s times 1 over s squared plus 1 plus 5 times s over s squared plus 1 plus 4 times 1 over s squared plus 1. Okay, finally, we're ready now to look this stuff up on the table. So y is going to be 1/2 this thing inverted. 1 over s squared inverted. That one is this one, where n equals 1. 1 over s squared is this one where n equals 1. So when you invert it, you get t to the 1, because n equals 1, for just t. So that's t. Then minus 1/2, inverting this one, 1 over s squared plus 1. It is this one with a equals 1. If a equals 1, this will be 1 over s squared plus 1. So it is really this one with a equals 1. So you get sine of 1t or sine of t. Sine of t minus 1/2. Now let's invert this one. This one is that one, an exponential times a function. So it's going to be u, the u c, where the c is, well, in this case is 6. So u 6 t. We're working on this one. Laplace inverse of this thing. Remember, not evaluated at t, but evaluated at t minus 6. Because that's what the formula tells me. It is little f, which is the Laplace inverse of this function, evaluated at t minus 6 in this case. Alright, so that takes care of that. This one is exactly, the same thing. Though you do it the same way, it's not the same inverse. So plus 1/2 e to the negative 6 times Laplace inverse of 1 over s squared plus 1, evaluated not at t, but at t minus 6. And then, now let's flip this one, invert this one. S over S squared plus 1 is right there, this one, where A equals 1, so that's the cosine of t. So plus 5 cosine of t. And that one is a sine, where A equals 1. So sine of t plus 4, sine of t. And now we're almost done. Um, so the answer is going to be y equals 1 half t, or just t over 2, minus 1 half sine of t minus 1 half u6 of t. Now the Laplace inverse of this, we already did it. The Laplace inverse of this is just t. So, but instead of t, it's going to be t minus 6 plus 1 half e to the minus 6s. The Laplace inverse of that we also pretty much did it already. Yeah, is this one. Sine. What is that one with a equals 1? It is sine, but not evaluated at t, evaluated at t minus 6. The sine of t minus 6, this one. Let me see, am I looking at the right one? Sine, and then, yeah, I did this one. The t minus 6, this is sine, yeah, that's correct. And then plus 5 cosine of t plus 4 sine of t. And that's the answer. The only thing you could do to simplify it is combine these signs that are like terms, and that's about it. So the final answer would be 1 half t. 4 minus a half would be 7 halves. 4 minus a half is 7 halves. Sine of t, and I'm going to put the cosine in front as well. 5 cosine of t minus a half u6t times, that's the actual times, plus a half e to the minus 6s sine of t minus 6. Okay, and this completes the hardest section in the whole semester. That's the answer for that problem.